going to look at the derivative of trigonometric functions, and we're going to find derivatives with them. So let's first start with f of x equals sine of x. If I estimate what the tangent lines look like at these different values, you might see some horizontal tangent lines right here and here on those hills, and some valleys. We definitely have a positive one here, maybe about +1, and then a -1 about there. So you can kind of see how at 0 we have a positive slope, at pi/2 we have a 0 slope, at pi we have a negative slope, and at 3 pi/2 we have a 0 slope. You end up, if we plot those, something that looks along those lines. By inspection, it looks like it's about f prime of x equaling cosine of x, which is true. So the derivative of sine of x is cosine x. I'm going to do the long, drawn-out process of how you can find that using limits in the difference quotient. So we would have the limit as h approaches 0 of sine of x plus h minus sine of x all over h. So the limit as h approaches 0, I can use my sum formula for sine of x plus h to get sine x cosine h plus cosine x sine h minus sine x all over h. When I look at these, this piece and this piece both have a sine x in them. So I'm going to group those pieces together for a moment. Sine x cosine h minus sine x plus cosine x sine h. We still have the limit as h approaches 0 on all of this. Since I have those two pieces separate, by limit laws, I can do the limit as h approaches 0 of this first piece plus the limit as h approaches 0 of this second piece. Okay. On this first piece, limit as h approaches 0, I could factor out my sine x out of those, and I have cosine h minus 1 h. And on this one, I'm going to kind of pull the cosine x to the front for a moment. I'm going to do that because now I'm going to actually split this into 4 separate limits. I'll have the limit as h approaches 0 of sine x times the limit as h approaches 0 of cosine h minus 1 all over h plus the limit of as h approaches 0 of cosine x times the limit as h approaches 0 of sine h over h. Now, in this first piece, the limit as h approaches 0 of sine x, there are no h's in that. So this piece right here is just sine x. Similarly, this piece, the limit as h approaches 0 of cosine x, that's just cosine x because, again, there's no h's in it to even do any substitution. So now I'm left with 2 separate limits that we might not know what they are. We don't have any tools to algebraically simplify them. There are different ways to do this. I'm going to look at the 2 graphs. So this first graph here shows me cosine x minus 1 over x, which is similar to with h's, but we want to look at 0. So from the left, what's the limit approach? And from the right, does it approach the same value? Yeah, and that limit is 0. So if I go back through this, that's 0. The other one, sine of h over h, if I look at that graph as h approaches 0, looks like this. As h approaches 0, we are approaching 1. You can see that my scale here is 2 on the y. Okay. So So we end up with sine times 0 plus 1 times cosine, which just comes out as cosine x. So the important thing to take away from here is that the derivative of sine is cosine. Just like that. The derivative of cosine is negative sine. Okay. So write those down if you haven't. Now, we're going to use the quotient rule to find the derivative of tangent. You remember from your pre-calculus, tangent is just sine of x over cosine of x. So I can use the quotient rule to help me find this derivative. So it's going to be the derivative of the numerator, which is cosine x, times the denominator, minus the derivative of the denominator, which is negative sine x, times the numerator, over the denominator squared. So cosine x times cosine x is cosine squared x. My two negatives become a positive, and then sine x times sine x is sine squared x. Remember those trig verifications that you may or may not have loved last year? Well, here's where they come into play. Cosine squared x plus sine squared x is equal to 1. That's a Pythagorean identity. Over cosine squared x. And so 1 over cosine squared x is secant squared x. So that's telling me that the derivative with respect to x of tangent x is equal to secant squared x. I could actually find the derivative of secant, cosecant, and cotangent as well, all using various product rules, and quotient rules. But I'm going to leave those for the viewer to do on their own. The rules are those. Here's all 6 trig derivatives in a nice, pretty chart. Okay. I'm going to do dy dx is equal to 3. The derivative of cosecant is negative cosecant x cotangent x. From that chart you just jotted down. Plus 4 times the derivative of cotangent x is negative cosecant squared x. We end up with negative 3 cosecant x cotangent x minus 4 cosecant squared x dy dx is equal to. We can also combine this with the product rule and have something like this, where we have f prime of x is equal to the derivative of u, 3, v, plus derivative of v is negative sine x, because derivative of cosine is negative sine x, times u. So we have 3 cosine x minus 3x sine x. Next one's a little bit trickier. Pause the video for a moment and see if you can find the derivative. But my recommendation would be not to use the quotient rule, but rather simplify first to see if you can make it easier. So hopefully you had a chance to try this problem. What I'm going to do is I'm going to work with it like a trig simplification first and try and reduce. So tangent x over secant x minus 1 over secant x. Well, tangent is sine x over cosine x over 1 over cosine x. And this is really 1 over 1 over cosine x. So if I simplify this complex fraction on the left, we end up with just sine x. And when I simplify 1 over cosine x, it's just cosine x. Now that I've simplified first, I can find my derivative and find that f prime of x is equal to cosine x minus negative sine x, or plus sine x. Much easier than finding the product rule of that bigger function. Last problem for today, and we've got find the equation of the tangent line to the curve at the given point. Well, first of all, it only told me the x value of the point, so I'm going to find the y value. So I'll find f of 0 first. We get 0 plus 1 times cosine of 0, which is 1 times 1, so f of 0 is equal to 1. Next part, I need to find the derivative. So I want to find f prime of x. Since I have the quantity x plus 1 times cosine x, I'm going to use the product rule. Even if I had distributed that cosine x in, I still would need to do the product rule for x cosine x. So, derivative of the first piece is 1 cosine x plus x plus 1 derivative of the second piece, negative sine x. So we have cosine x minus sine x times x plus 1. Now I want to find out, lots of x, f prime of 0, it's going to be cosine of 0 minus sine of 0 times 1. So that'll be 1 minus 0 times 1, which is just 1. So I want to write the equation of the line with a slope of 1 that goes through the point 0, 1. We'll just have y equals x plus 1. And that concludes this